Randy Palachek and Dr. Kirk Dean, both with Parsons, talking on Dioxin, a San Jacinto Waste Pits legacy. Parsons has been instrumental in helping the county attorney's office deal with all the litigation and all the commenting we've been doing on the San Jacinto River Waste Pit Superfund site. Randy Palachek is a senior technical expert with over 30 years of experience in the area of environmental risk assessment, regulatory analysis, watershed assessment, TMDLs, water quality standards, hydraulic modeling, and biological studies. And Dr. Kirk Dean is a principal scientist with Parsons and a senior project manager. His primary expertise is in applying mathematical models and quantitative analysis, and his Ph.D. was on dioxins and aquatic systems.
Thank you. I am Kirk Dean. Randy's going to give the second half of the presentation. On this title slide, you can see a number of the signs alerting people to stay away from the San Jacinto Waste Pits site and various sites around the ship channel area in Galveston Bay, warning people not to eat more than a meal of fish a month. Legacy of, in part, the San Jacinto Waste Pits. Not to imply that that's the only source of dioxins in the system, but it's one important one. I'm going to present an introduction to dioxin and the science behind dioxin, the discovery of the problem in Galveston Bay and the ship channel through the TCEQ TMDL program, a history of the San Jacinto Waste Pits site, and Randy's going to go through the activities that have occurred under the EPA Superfund program and site remediation. Dioxin is actually not a single compound, but rather a group of compounds that exhibit the same kind of toxic behavior. Jumping around to the bottom of the slide, the most toxic congener is 2378 tetrachloro-dibenzodioxin. There's a picture of it down here at the bottom right, but it's only the most toxic of a group of 29 compounds, for those of you who are good with math, although the slide says 31. 7 dioxins, 10 dibenzofurans, and 12 PCBs that are all very toxic at very low levels. They're extremely persistent in the environment. We're talking about potentially hundreds of years. They tend to, although they occur in water, they really accumulate in tissues of fish and crabs and even in humans to levels 10 to 100,000 times the level in water. And in aquatic systems, they primarily bind up in the sediments. They are toxic. They can affect human health at extremely low levels. One of the more toxic substances known to mankind. And they are not intentionally produced in any process, but they occur as a trace byproduct in a number of processes, everything from production of chemicals to bleaching of paper mill, wood pulp, and even in things such as forest fires. When we're talking about the San Jacinto Waste Pits, we're talking about things that originally occurred in the 1960s. Dioxins were first mentioned in the scientific literature, really in any practical amount in the middle 1960s. This figure shows the number of references to dioxin in the scientific literature each year. And from a few reports per year in the 1960s, that number has increased fairly steadily until the mid-2000s. And some of the drivers of that expansion and the knowledge about dioxin were the Vietnam veterans exposed to Agent Orange in Vietnam, the Times Beach, Missouri contamination, the explosion of a pesticide factory in Seveso, Italy, the uncovering of a lot of buried waste in Love Canal, New York. These fueled a lot of research into the health effects of dioxin and really the ability to measure it, because it is present at such low concentrations that until new analytical methods were developed in the 1980s, it really couldn't be measured in water and barely measured in soils. So with all this focus on the potential health effects of dioxin, EPA in 1985 finally declared that it was a probable human carcinogen. In 1990, the Texas Department of Health issued a fish consumption advisory, actually for crabs, in the Houston Ship Channel, Upper Galveston Bay, and the lower San Jacinto River and tributaries to that whole system for dioxin. In 1996, the Ship Channel was added to the Clean Water Act 303D list of water bodies that have impaired uses. And in 1999 or 2000, the NRCC, which is now the TCEQ, initiated what's called a TMDL project, Total Maximum Daily Load, which is intended to limit discharges into the system for a pollutant that's already present at too high of a concentration. And that project included a lot of sampling and analysis. I will describe that in a minute, but moving to the last little key date here, in 2008, EPA added the San Jacinto waste sites to the Superfund National Priority List. I already showed that slide. So the TCEQ's TMDL program involved a large amount of sampling. We sampled all different media. This was led by University of Houston and Parsons, with support from a number of laboratories and some other firms helping out. In order to sample water runoff and effluents to the Ship Channel and Bay system, we had to collect large volumes of water. These samples that are shown on the left and the right, we would typically sit on site for about 8 hours and collect about 600 liters of water to be able to quantify the dioxins in those sample. We also collected fish and crabs throughout the bays and Ship Channel, and also did monitoring of sediments and atmospheric, both the levels in the air as well as the deposition in rainfall and dry deposition of dioxins to the land surface into water. And the key findings of that TMDL sampling that was done from 2002 through 2005 was that the water quality standards were exceeded in more than 80% of the water samples, and more than 95% of the fish and crab tissues violated water quality standards. A second key finding was we had kind of thought that the time of dioxin discharges peaked back in the 60s and 70s, and that it would have been declining since that time. In fact, we found that the dioxin levels in the fish and crabs were stable from when they had been first measured in the 80s and 90s. There were a couple of hot spots of environmental contamination that were identified. One of them was a station that we had at the San Jacinto River at the I-10 bridge. A second one was in the Buffalo Bayou portion of the Ship Channel, near where Pasadena and Deer Park occur, just downstream of the Beltway 8 bridge over the Ship Channel. We found that the existing loading to the system from the atmosphere, from runoff from land, from the point source discharges of wastewater, could not support the levels of dioxin that we found in the water. The math just didn't add up. There was some other source that we couldn't identify, and the most likely source, and one that's been found elsewhere, is that historical contamination bound up in the sediments is being mixed back and diffusing back up into the water column and accounting for 80 to 90% of the total amount of dioxin in the water. In order to address the hot spots, some additional sampling was done. The dots on this figure to the right show the sampling points. The sampling was done over a regular grid. This shows the hot spot near the I-10 bridge on the San Jacinto River. And one point really stood out. That's the red dot there with a concentration of about 33,000 nanogram per kilogram. In terms of dioxin, that's a lot. The highest level that we measured in sediments anywhere else in the system was 846 nanogram per kilogram. So in that hot spot, at least we were able to identify a locale where a lot of dioxin was probably coming into the system. And a Texas Parks and Wildlife employee who'd been working there for a long time remembered that once upon a time, way back, there had been some waste pits there on the banks of the San Jacinto at I-10. And that outline is shown there with the red line where the former waste pits were. At the other hot spot in the Buffalo Bayou portion of the ship channel, we were not really to identify a discrete source. There were a lot of potential sources in that area of the ship channel, a lot of industrial discharges and municipal discharges, and there was no single hot spot that popped out from the high resolution sediment sampling. Now I'm moving to more discussion on the San Jacinto Waste Pit site. This picture was taken in September 1956, and it shows what the area looked like before the development of the waste pits. You may not remember that there was once a second bridge, an earlier bridge over the San Jac River there that was demolished at some time, but the I-10 bridge there, although I think at that point it was Highway 71, remains much the same today. To the north of the bridge, you can see that the area where the waste pits were installed was at that time a low marshy area with a lot of water and wetlands, and the area to the south of the bridge was like a sandbar. In 1964, Ole Peterson and Company excavated a waste pit to the south side of the bridge that you can see here, the outline of where they were working on building those waste pits to the south side. Another thing I should point out on this slide, up near the top middle portion of the river, you can see some odd shapes, and that's primarily because of sand mining activities that were going on in that area and they're still going on near that area today. The next year, in 1965, McGinnis Industrial Management Corporation built this waste pit on the north side of I-10, largely just by bulldozing the marsh, filling in the low areas, and creating berms of 5 to 7 feet around the future waste pits. In that time frame, the Champion Paper Mill in Pasadena had settling ponds on their wastewater treatment system that had solids building up in them, and they needed to get rid of the solids. They contracted with Ole Peterson and then McGinnis to dredge out all those solids to a barge as shown on the left, and then they pumped them or barged them over to the San Jacinto River area and emptied them into the waste pits. That was from 1965 to 66 when all that happened. By late 1966, there are already problems beginning to appear. And first of all, in addition to the lack of knowledge about dioxin at this time and our inability to measure it at the levels where it was present in the environment, there was also limited environmental regulation at this time, both in terms of laws and in enforcement. The levees that were constructed were weak. As you can see in the northern corner of this slide from fall of 1966, the berms around the site are already collapsing and letting water out of the northeast waste pit into the river. There were also issues with land subsidence. There were the issues with the sand mining and flooding, and eventually in the 1970s the pits were just abandoned. This shows a flood in 1994. The waste pits are approximately here. I can point out where that billboard is, but they're largely covered in water in that flood. And at that time, they were completely unprotected from the surface. Also note there were some loose barges even present then. This slide shows a couple of pictures of the site showing the changes between 1973, when the levees were still slightly intact at that point, although there was some escapes, to 2006, when a number of changes have occurred. First of all, I want to point out that the southern waste pits here had been filled in. The company got permission from the Texas, what was it at the time, the Water Quality Board allowed them to dewater the pits and discharge that all to the old San Jacinto River channel, and then filled in the waste pits. But the ones to the north of I-10 were still exposed. Some of the sand mining operations, if I go back to one of these slides, you can see where there was a little finger pointing towards the waste pits from sand mining. That in turn, combined with the force of the river, created a new channel that, if you look at the 2006 photo, has turned into a whole new channel that just eroded away the whole dike along the east side of the waste pits and the northern part of the western waste pits. So here I'm going to turn it over to Randy.
Okay, thank you, Kirk. So as you can see, it's been a long road just to get to this point. And without the TMDL process going on, with TCQ, with Parks and Wildlife, and all people bringing up and trying to find what the smoking gun was in here, then we finally had the data to take the EPA in the 2005-2006 timeframe with that TMDL and the fish tissue studies, the water sampling data, etc. So then EPA picked that up and kept continuing on with it to develop the preliminary assessment and site inspection reports from 2006 and continued to dig into it, do more research about what was there before, those type of things. So it ended up proposed in 2007 and adopted by EPA in 2008, the Superfund listing process, or listed the site. They continued to do the research, continued to do the remedial investigation, the feasibility study, and in 2010, they determined that they needed to do time-critical removal because of all the erosion and washing out of the levees and the berms. Then they ended up having to go in there and do a removal action on some of it and then put on a quote-unquote temporary cap that was supposed to last about 7 years, which would take care of solving all the problem in that 7 years. Well, that's where it's just continued to take more and more time to address the situations. But so after doing all the remedial investigations, the feasibility studies, EPA came out in 2016, so 8 years after the initial listing, in 2016, with a proposed plan for what to do with the pits, the waste pits. There was a lot of discussion going back and forth, and in 2017 then, EPA published and adopted the ROD after going through several rounds of comments or responses and looking at all the possible options that are out there, which brings us up to almost current time frame, which the PRP group has agreed to do the remedial design. They anticipate it'll take 2 or so years to collect additional geotechnical data, come up with a design and approach for how to go in there, do the complete removal of the waste pits. And then we're kind of anticipating, the estimate is the remedial action will take place from 2021 to 2023, 2024, somewhere in that process, or in that time frame rather. So I wanted to point out that Harris County has been working on this for a long, long time and at very high levels. Harris County Attorney's Office and Pollution Control Services Department have worked closely with the local and state agencies, Parks and Wildlife, the Health Department, the Port Authority, TCEQ, Galveston Bay Foundation, and other environmental groups as well. And they've gone to EPA in Washington, they've gone to the EPA in Dallas, they've gone to Austin to meet with officials and keep pushing forward the issue that we've got to clean up this issue because the ship channel in Galveston Bay is such a resource for recreational, for fishing. We've got to solve this problem and get it cleaned up as much as possible. So, that throughout the years from 2008 forward, there's just been a constant series of documents being published by EPA, Harris County review, and commenting and working with EPA to try and do the best cleanup possible out there. In November of 2014, Harris County also filed a lawsuit on the 2 PRPs. They were able to settle with one of those, and then the money they've gotten in from that has gone back into the area in terms of trying to improve some of the parks, working with Parks and Wildlife on that, and then also performing the water well sampling that was done around the pit area on both sides of the channel, the fish tissue sampling, and then additional work with community involvement. A big part of the evaluation in more recent years has evolved around the cap and how well the cap is, how well it can be maintained until we get to a point to where we can make a final remediation. The Corps of Engineers has done 2 cap evaluations, including one that had to come back and look at more about barge strikes being an issue, which came up during the time frame in 06 and 07, and then prior to that too. But so, they've continued to work with the cap, having to put on bigger stones onto the cap and fortify it better to keep waste from coming into the channel. And in current time, 2019, July, the EPA and PRP group put out the pre-design investigation work plan and the treatability studies, those type of things as to how they're moving forward. And so that's where we are currently. So things are still moving forward. So just to show issues with some of the caps, I mean, it's been an annual issue. As you can imagine, I mean, you can't stop Mother Nature. The flood waters coming through there is very, very strong. And so there's been numerous times when the cap has had some erosion around the cap, when they've tried to fortify it more after the Corps of Engineers reports, putting on heavier armor, especially on the eastern cell, like what Kirk was showing, where the sand dredgers had come into that area and then it eventually eroded all the way through, washed all the way through, and created a short circuit going right under the bridge. And then that flows right across that eastern cell, right across the berm areas. And so that's just a constant area to try and maintain. This is from 2016 erosion of the areas that are in the orangish red type areas. Actually was a 6, 7 to 8 foot deep scour that occurred across there, and that's where I was saying that the sand dredgers cut a path kind of through part of that, and then the floods washed it out the rest of the way. But that's where there was actually a 7 foot deep trench that was found through there where it washed away that edge of the cap, and so that had to be fortified a lot with the additional armament and putting in larger and larger rocks in there. So it just shows some of the constant issues that are coming up with the flooding that we're having every year. In 2017, we had Harvey and the damages there. So these are a few pictures. You can see where the exposed geotextile is, and the large rocks have been washed away where the floodwaters cut across there, exposing the geotextiles. So part of the issue and where EPA ended up settling in, so EPA's rationale ultimately for removing all the material is that we're going to constantly have this armament problem. So if you leave this stuff here for 100 years, it's going to come up and be an issue every year for 100 years. You've got to go continue to do quarterly monitoring out there, send divers down, do geophysical surveys, etc., to try and determine where you may have some cap erosion, where you may have issues. So, previously in the 70s, the 80s, we had a lot of land subsidence. So it took the marshland, obviously, and it moved it down. It became more water in that area. There is the potential for sea level rise over the next 100 years. You've got the increasing frequency that we've been kind of seeing lately with the 100-year, 500-year floods, the hurricanes, etc. Also with the fact that Lake Houston isn't able to store, large floods when they come through there. You're not getting any capacity storage from there, so therefore, we're not getting any help to protect the pits downstream from that. River channels always move around. They're going to constantly move back and forth because of the force of the water. So it's hard to maintain something sitting in the middle of the river when it's going to constantly get washed away and have the forces on it. The bridge causes a real constriction right there. You can see on some of the bridge how narrow the channel is going through there. And so therefore it's always causing a constriction to increase the velocities through that area. So in addition to it being hard to maintain for the floods, you're also increasing the velocities going underneath the bridge right there. We've got several accidents that have happened, including the barges going up onto the waste pits in the area. So it's a continued issue. Ultimately, obviously, we're all really about recreation, fisheries, protecting the public, and so that's what we've got to really do to protect that from continued erosion and continued exposure. So the way that they're planning on doing it in the EPA ROD is basically to construct a high cofferdam all the way around, heavy steel metal cofferdam around this, and then go in there and excavate it out in the dry. Obviously, the cofferdam is going to have to extend up 15, 20 feet or more in the air to protect it for when the floods, when the water level rises. Because you want to protect as much as you can. If you also see a hurricane happening out there, the other theory or the other aspect of the construction is to only open up small pieces at a time. So if you think of it as a pie, you're only going to eat one slice at a time. That way everything else isn't exposed in order to get washed away in case water was to ever come over the top of the cofferdam, or in case the cofferdam got damaged and water came over or something. So number one, hopefully you can see and predict out, like when a hurricane's coming in, just like they do with the oil rigs out in the Gulf. I mean, they know when a hurricane's coming in, they know if they've got 2 or 3 days to get people off the rig, same thing. So you get in there, you close it out, armor it, put it down, and you've only got a small sliver or a small section of pie open at a time. So therefore, it'll take a little bit of time to do it, but hopefully doing it that way, it'll be able to do safely be performed to excavate that material out that's in those pits. So talking about the barges, I mean, you looked at the early photos from when that Kirk showed in the 60s, the 70s, et cetera. There weren't barges up there. And just for comparisons, in 2012, there's about 10 barges at this site close to the pits, whereas in 2019, this aerial photo shows about 60 to 70 barges. So there's a lot more barges obviously being stored up in that area now. We're shipping a lot more things like Jim was talking about earlier. We're using barges, containers, et cetera, for a lot more shipping, and the port traffic is increasing and increasing. Therefore, you got to have more places to store the barges around and whatnot. So one of the key aspects to look at then is how can those barges get secured a lot stronger when a storm is coming? Can they get moved south of the site, south of I-10 when a storm is coming? Other things to do. I think there's a number of actions that people will have to consider in order to do something about that, to where they can work and put in some kind of a plan, kind of an emergency type of a plan that says, okay, when a storm's coming, we're going to do A, B, and C to secure the barges, move the barges, etc. So here's a couple of other photos. As you can see, the barge is stuck out here on the site, right there in the middle. The white containers over here are on the waste pit sites by the central ridge there. Those are containers that they've got out there for their supplies and whatnot in terms of doing testing and working on the pits. So those stay there, and that central ridge is kind of the center part of the site. So you can see the barge is stuck right there, so that's an issue. The barges can run up aground on there and then take off some of the top part of that cap, exposing potential soils. And of course, everybody has seen these videos where they've hit and damaged, where the barges have damaged the bridges. Obviously, that's a big concern for the barges coming and swinging through there. So not only was that one barge on the site, but there were 2 or so other barges that came across the site that EPA and the PRP group will have to go out there with their divers and look for any other damage that may have occurred. So other recommendations in terms of doing the remediation on the site is obviously try to work when it's not hurricane season, get as much stuff as you can get done when it's not hurricane season. Uncovering it in these small pie-shaped areas at a time. If there are the impending storms coming, backfill over it. Also, several of the EPA's other remedies that didn't require the complete removal included putting in a heavy berm on the upstream side of the site, or putting in bollards filled with concrete and anchored 20, 30 feet into the ground, so that you can put pilings ever so often or something ever so often to keep the barges from coming onto the site. Since it may be until 2024, 20 or so, since the work gets completed, probably should consider some of these other alternatives in the short time frame to help protect the site before the real remediation gets going. And I think with that, Kirk and I are done. So, any questions? Yes, sir.
Have there been any health studies to find out how many folks have been impacted by the dioxin?
I know the ATSDR has done their evaluations and their report because it's part of the Superfund process. And I know the state health department have done some. And in terms of exposure to that particular dioxin from that particular site, I don't know. Basically you would be exposed because you were eating fish right from that area or eating crabs right from that area or something. So it would be exposure that way.
No, I was thinking about that because in Lake Charles, the community of Mossville, in the Westgate area, they had an underground plume, dioxin. And that entire community has been relocated except for some that refused to move because of their long history there. And but anyway, they used health. Well, they tested the community and they found there was dioxin and symptoms of what they caused it, right? So I was just wondering if a similar study had been done for that area, including looking at fishermen, shrimpers, whatnot.
Yeah, and the ATSDR study for the Superfund listing process in 2008 included some of that type of evaluation from that time frame.
Yeah, the Texas Department of State Health Services also did a study that looked at health levels and various types of health outcomes measured close to the site but in parity distances from the site. And it did seem like there were a few types of cancer that might be elevated there relative to further distances from the site. So, but quantitatively, I don't know that they could say how much of that was from dioxin in particular, but just that there were elevated incidents of some types of cancer.
Yeah. Yeah, Latrice, you may know more about that study or.
I know that there was a survey that the state health department did as far as like doing blood work to determine health levels. I'm not aware that anybody's done that.
Yeah. Yes.
On slide 24, there was a picture of where the construction workers aren't seen with any personal protective equipment. Are all of them informed that they're going to be working in a contaminated site? Like sometimes I run into workers and they told me they share previous experiences where they were never told that they were working in a contaminated area. So like, what's the safety procedures for them in areas like this?
Well, they have a health and safety plan out there right now for doing all the investigation, and all of that is identified in the health and safety plans. So whoever the contractor is doing that work has got to inform their workers on those issues. So that'll be, it's in the health and safety plan as to the chemicals of concern, and that they may be, sampling, and obviously you need to wear proper PPE for doing that.